Sanjay, and in this video we will write a program for range sum of BST. This is a very popular problem and has been asked in Facebook multiple times. So let's try to understand the problem first. So in this problem we can see from the description that given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with a value in the inclusive range of low and high. So what does it mean? We have to find all the numbers in the binary search tree which are in the range from low, which is 7, and high, which is 15. So we can see from in this tree that the numbers which are coming in the range are 7, 15 and 10, and if we sum them up then we are getting 10 plus 15 25, 25 plus 7 32. Let's take another example. So here the binary search tree and low is 6, high is 10, and if you find the number which are coming in this range, then the numbers are 6, 7, 10. Yeah, that's it. And if we sum them up then the value which we are getting is 10, 7, 17, 17, 6, 23. So 23 should be the answer. Now let's find out the algorithm, how we can solve this. So one approach is we can use a linked list. What we will do is we will push the node in the linked list, and while popping it we would check whether the node value is coming in the range from low to high or not. If that is coming in the range, we would sum them up, and if that is not coming in the range, we would simply add them into the queue. We will continue this process until the queue is empty, and then we will return the result. So let's write our solution. So first we would take our result variable, we would return the result, then we would take one queue which will be of tree node type, and then we would add root node to the queue. We would check our conditions until the queue is empty. So when we are getting the queue is empty, then we will come out of this loop. Now we would check that the node which is currently held by the queue is greater than or equal to low, as well as less than or equal to high. If this condition satisfies, then we would simply add the value of node to our result, which is this. Else we would simply check the left and right node, and if they are available, then we would simply add them into the queue. We can use offer or we can use head, both are same. Just there are some minor difference, but for our purpose this both will work. So yeah, if we have the left node, we would enqueue that node to the queue. If we have the right node, we would enqueue that node to the queue. And if our queue is empty, in that case we would simply return the result. Now let's check if that's working or not. Okay, so sample test case is passing. Now let's check for all the cases. Okay, so this passing for all the test cases. Now let's discuss about time and space complexity. So since in this solution we are touching all the nodes of a binary search tree, so the time complexity will be order of n. Now what will be the space complexity? So the space complexity would be in this queue we are taking the maximum two levels of nodes. So if we are in this node, then we are taking these two elements. If we are at this node, then we are taking this element. So maximum two levels of nodes we are pushing into the queue. So let's see from this example. So if we are at this tree, we are popping 10 and we are pushing 5 and 15. If then we are popping 5, we are pushing 3 and 7. Then we are popping 15, we are pushing 13 and 18. So we can clearly see that we are maximum using two levels of node. So the two levels of node, it means it will be order of n by 2 plus something, because the maximum values at any level in the tree would be order of n by 2. So it would be order of n by 2 plus one level up nodes. So we can say the space complexity would be also order of n. So yeah, time complexity and space complexity will be order of n.